Hello! Welcome to today's lesson on further motion equations. In today's lesson, we will discuss the equation v squared equals u squared plus 2as, which is included in your formula sheet. We will then walk through the variables involved in this equation and how they relate to each other. Finally, we will go through some worked examples to show how to use this equation. So far, you have become familiar with key concepts such as displacement, velocity, speed, and acceleration. Building on this foundation, understanding the equation v squared equals u squared plus 2as will enhance our ability to solve problems involving motion and acceleration more effectively. Let's get started. The equation v squared minus u squared equals 2as is a kinematic equation that helps us understand the relationship between an object's final velocity, initial velocity, acceleration, and displacement. It's included in your formula sheet and can be derived from a velocity time graph. Let's go through the variables in this equation and their units. Final velocity, v is the velocity of an object at the end of the time period. It is measured in meters per second. Initial velocity, u, is the velocity of an object at the beginning of the time period. It is also measured in meters per second. Displacement, s, refers to the change in position of the object. It is measured in meters, m. Acceleration, a, represents the rate at which the object's velocity changes over time. It is measured in meters per second squared. One essential point with this formula is that it can only be applied when we are dealing with uniform acceleration. That is, the gradient of a velocity time graph must be straight for us to apply this formula. Let's consider some practical scenarios. Suppose a car accelerates from 10 meters per second to 30 meters per second over a displacement of 100 meters. We want to find the car's acceleration. We are given the initial velocity, u, which is 10 meters per second, the final velocity, v, is 30 meters per second, and the displacement, s, is 100 meters. To find the acceleration, a, we use the equation v squared minus u squared equals 2as and rearrange it to solve for a. The rearranged equation is a equals v squared minus u squared divided by 2s. Then plug in the values. Doing this, we get a equals 30 squared minus 10 squared over 2 multiplied by 100. This simplifies to 900 minus 100 over 200, giving us 800 over 200, which equals 4 meters per second squared. So the car's acceleration is 4 meters per second squared. Suppose we have a different scenario where a car accelerates over 150 meters and its initial and final velocities are 20 meters per second and 50 meters per second, respectively. We need to find the car's acceleration. First, identify the values. The initial velocity, u, is 20 meters per second, the final velocity, v, is 50 meters per second, and displacement, s, is 150 meters. Use the equation a equals v squared minus u squared divided by 2s. Plugging in the values, we get a equals 50 squared minus 20 squared divided by 2 multiplied by 150. This simplifies to 2100 divided by 300, which gives 7 meters per second squared. Thus, the car's acceleration is 7 meters per second squared. Let's recap some central points that we've covered. Only apply this equation when acceleration is constant. It will yield incorrect results in any other cases. Always ensure units are consistent. For example, velocities must be in meters per second. Double-check arithmetic steps, especially when squaring numbers or rearranging the equation. Familiarize yourself with the formula's rearrangements to solve for different variables depending on the given information. By mastering this equation, you will enhance your problem-solving skills in physics. This will allow you to tackle various questions related to motion, making it easier to understand how forces and motion intertwine. Now try a few practice problems on your own to solidify your understanding. In today's lesson, we covered the kinematic equation v squared equals u squared plus 2as and its application in solving physics problems related to motion and acceleration. We began by understanding the formula and defining its variables: final velocity, v, initial velocity, u, displacement, s, and acceleration, a. We then applied the equation to practical examples, calculating acceleration given initial and final velocities and displacement. Understanding and applying this equation is crucial in physics, as it helps us solve problems involving uniform acceleration, especially when the time duration is not provided. We emphasize the importance of consistent units, careful arithmetic, and the ability to rearrange the equation to solve for different variables. Mastering this equation enhances problem-solving skills and deepens our understanding of the relationship between forces and motion. Watch the rest of the GCSE physics course at Sophos Education.